Hello everyone, I'm Itoshi and today I'll be presenting our paper titled Comparing Visualizations to Help a Teacher Effectively Monitor Students in a VR Classroom. Educational virtual reality applications are the most recent addition to the learning management tools. People are looking for alternate ways to teach and learn. The ease of access and also the availability of cheaper VR devices had made educational VR applications a real possibility. Educators around the world are looking for better teaching techniques and remote classroom management tools. An efficient VR-based teaching interface could enhance student engagement, learning outcomes, and overall educational experience. VR has been shown to improve teaching skills. However, teachers in a VR classroom do not have a way to know what students are doing since students are not visible. An efficient teaching interface should include some mechanism for a teacher to monitor students and alert the teacher if a student is trying to catch the attention of them. An ideal interface would be one which helps a teacher effectively monitor students while teaching without increasing the cognitive load of the teacher. In this paper, we present a comparative study of two such student monitoring interfaces. We present a detailed user experiment comparing the two interfaces in terms of teaching management, student monitoring capability, cognitive load, and user preference. Several researchers have emphasized the importance of real-time classroom awareness and how these interfaces are aiding in improved teaching performance. The figure on top right shows the relative frequencies of different types of knowledge teachers used following a dashboard consultation in the study conducted by Moliner and colleagues. Radianti and others did a focused systemic study on the evaluation of educational VR applications for higher education and discussed how there was an increase in interest in immersive VR technologies for educational purposes. In their paper, they used the graph to show the percentage of VR device uses for educational VR. 76% of the VR devices used were high-end HMDs like Oculus and HTC Vive. Research can also be found that discusses how teachers felt the need to improve the mechanism in VR-based instruction system. Holstein and co-authors used mixed reality smart glasses to place 14 indicator symbols for actions like misusing the software, unproductively struggling, recently doing well, idle, etc. over empty student seats. The figure on top right shows the teacher's point of view while using smart glasses in Holstein's system. The bottom picture is the screenshot taken after the end of a class session to protect students' privacy. Although students' cognitive load has been a consideration, not much research has been found that takes into consideration the cognitive load of the teacher while using the educational applications. The figure shows the most common methodologies adopted for cognitive load evaluation according to DIGEC and others. The work of Uihan discussed the challenges to quantify cognitive load through various measurement methods and suggested that numerical scales can better reflect cognitive processes underlying complex problems. We designed an interface for teachers for our experiment. I'll show the picture after a couple of slides. It has a VR classroom with 30 students' avatars placed at arbitrary locations inside the VR classroom. Each student is represented by an avatar. The name of the student is shown on top of the avatar. The classroom had a whiteboard which worked as a slideshow presenter which the users could use to teach the class. Students had their names appearing on top of their avatars. Students in the environment would arbitrarily do nothing or present one of the three action states: raising hands, speaking, or typing. The action states were represented by action icons as you can see on the right side of the slide. In an actual classroom, a teacher can see the students in front of them. They can track their movements and body language and address the students when needed. While all students are important for the teacher, sometimes students might want to ask a question or need assistance. The easiest way to attract the teacher's attention is to raise their hands. So we tag the students who need immediate attention of the teachers as important students. We had two versions of the teaching interface. First, we'll talk about the avatar located icons interface. Here you can see the image of the interface with student avatars with their names on top of their avatars. In this version of the interface, student action icons appeared on top of the avatar. Next, we have the indicator located icons interface. In this version, all student avatars have a representative emoticon-like visual indicators which are arranged centrally in front of the teacher. The indicators are stacked in 3 rows with 10 indicators in each row. The indicators had colors ranging from red to green based on the simulated student's attention state. The green color represents attentive students and the red represents highly distracted students. Action icons appear right on top of the emoticon indicators. A red tether connecting the emoticon and the student avatar appears when a student becomes important. Next, we'll talk about the user study we conducted to evaluate the effectiveness of the two interfaces. Our independent variables were interface type and the number of important students. Each participant had one trial for each interface type. For both trials, simulated students would randomly raise their hands, speak, or type. The number of important students would be 1, 3, and 5 during the lesson. 6 other random students could be found typing or speaking at any random time To emulate a busy class, the classroom had 30 students in total. The dependent variables were participant heart rate, lesson duration, which means time it took the participants to complete the lesson, average response time, which is the time it took the participant to notice an important student, and participants' self-assessment of their cognitive load, classroom management, and teaching performance. Additionally, we also asked the participants to compare the two interfaces based on their preference. At the starting of the study, we gathered the demographic data and asked the subjects to fill up a prior experience questionnaire. Our study was a within-subject study with 26 males and 4 females in the age group of 19 to 35 with a mean of 23 years. Out of the 30 participants, 27 had prior VR experience, 12 participants had used educational applications, and 7 participants had prior teaching experience. The subjects ran through an training scene where they practiced what they do in the trial. They were shown how action icons appeared in the two versions of the interface. They tried how looking at a student with raised hands for 3 seconds straight removed the hand raise icon, indicating the participants had correctly identified students with a raised hand. The participants were made aware that the students' avatars were simulated students and they did not need to answer any questions or do anything else other than looking at the raised hand students. In the training scene, participants ran through the slides to prepare for the teaching task. After the training phase, the participants either tried the avatar located interface or indicator located interface. The participants taught the students using the slides and looked at the students when they became important. Once the participants were done teaching the lesson, they took a break and answered questions regarding their cognitive load and self-evaluated their classroom management experience. Lastly, they completed a questionnaire comparing the two interfaces along with stating their reasons for their choice. The figure on the right shows the average response time for both the interfaces with increased number of important students. There were significant differences in response time for the two interfaces and for different numbers of important students. The figure shows increase in heart rate from the baseline for each interface type. Although the average increase in heart rate was slightly higher with avatar located interface, we found that there was no significant difference between the two interfaces and for different number of important students. The figure shows average lesson duration for the two interface types. The results indicate that there was a significant difference between the two interfaces in terms of lesson duration. The figure shows the mean ratings of the self-evaluation questionnaire responses. For all questions, participants evaluated their performance significantly decreased with increase in number of students. Significantly more participants felt that they could attend to individual needs more with the avatar located interface. Significantly more participants felt less need to stop during their lessons while using the indicator located interface. The indicator located interface was significantly adequate compared to the avatar located interface when 3 important students were present. The figure shows the mean ratings of the cognitive load questionnaire responses. All cognitive load significantly increased with increase in the number of important students for both interface types as expected. Participants reported significantly less physical and mental demand while using the indicator located interface compared to the avatar located interface. Participants felt they needed to work harder and was more frustrated with the avatar located interface. The figure shows the participants' responses when asked to choose between the two interfaces. In general, 22 participants out of 30 were inclined to use the indicator located interface. 18 participants liked the indicator located interface more as it showed exactly where the student was. 24 participants thought indicator located interface was more effective. One limitation of our user study is that most of our participants did not have real experience as a teacher. The students in the experiment were simulated students and this could have some effect on our results. However, it still gave us a chance to evaluate the two interfaces on a teaching task. Additionally, the teaching task was for a short duration. Furthermore, only 13% of our participants were females and this could have created a potential gender bias. In this paper, we presented a comparative study of two such student monitoring interface, avatar located and indicator located. We did a detailed user experiment to compare the two interfaces. Our results showed that the indicator located interface is better since it made it easy to monitor students as indicated by lower response time and lesson duration. Additionally, this interface did not significantly increase the cognitive load of the participants. In the future, it would be interesting to see if using other EEG sensor data can help us understand teachers' cognitive load better. Additionally, seeing how using the interfaces affect the way a teacher addresses and responds to a student when they're asking a question could be interesting. Furthermore, it will be interesting to see how the interface performs with real students. That concludes my presentation. Thank you.